Alright, so I left off in the last video showing you how you could just quickly compute the area of each one of these rectangles and add them together and get your left endpoint approximation. Now, let's say that we're given a problem where we have to use these summation formulas. Like it's a longer problem, or it's just something you're told you have to use the summation formulas to solve this question. You can't just add the rectangles up together, or just, go one by one and add them together, add up the areas. So in order to use these summation formulas, we're going to have to break it down into these forms. And the way we do that is first we got to come up with a function, a summation, as I goes from the first rectangle, the first iteration, to the fourth rectangle. As I goes from the first to the fourth, will add up to the sum of the area of each one of these rectangles. And hopefully I can show you what I mean by that. So we know our summation is going to go from I equals 1 to 4. We have 4 rectangles. We have 4 iterations of adding together. And we're going to have some function f of x times 1/2 is actually going to be some function of I. Some function of I 1/2. And the reason is we need to run f of the first iteration, f of the I1, that gives us this height, f of our I2 that gives us this height, f of our I3 that gives us this height, and f of our I equal to 4 that gives us this height. So how do we do that? How do we do that? Well, our first height of the rectangle is f of 2. So, So our first rectangle is f of 2. So we're going to have f of 2, but we still need to put our I term in there. That way we can get every rectangle afterwards as I goes from 1 to 4. Well, for a left endpoint, you're going to need to still run the first rectangle at 2. So when I equals 1, this will still have to equal f of 2. So what we can do is f of 2 plus I minus 1. That way when I equals 1, this is 0. But we also know that each one of these rectangles are changing by 1/2. So our second I would have to bring us to f of 2.5. Now if we just leave it right here and close this off, we would get f of 2 at I equals 1, and then I equals 2 we get f of 3. So we would actually skip this rectangle. So the way we do that, f of 2 plus I minus 1 over 2. I'll draw that a little bit better. I minus 1 over 2. Now that gives us the height of each rectangle. So when I equals 1, that gives us f of 2. When I equals 2, that gives us f of 2.5. When I equals 3, that gives us f of 3.0. And if you don't believe me, you can just try it out. Or if you don't trust it, you can just verify it. Go through and see if it accounts for every one of the heights of the rectangles. And we still need our width in there, because remember, area of a rectangle is base times height. We have our height. Well, our base is 1/2. So f evaluated at this function, as this function, times 1/2 will give us the area of each rectangle as I goes from 1 to 4. Now, this is where things get a little lengthy. So we have to plug this value here, into our function up here. So what will that look like? Well, we have f of x equals 2x squared minus x minus 1. Let's plug this into all of our x values. Leave the 1/2 out, where you're plugging this into all of your x values. So we have a summation I equals 1 to 4. Let's scroll down a little bit more. 2 2 plus I minus 1 over 2 squared minus 2 plus I minus 1 over 2 minus 1, and all this in parentheses, times 1/2. Really, this is the same thing as saying this, but now we've actually plugged this in for all of our x values. We've plugged this in for all of our x values. Now what we're going to do from here, to make this a little easier, we can simplify this term down here. We can simplify the 2 plus I minus 1 over 2 to make things a little simpler. Well, 2 plus I minus 1 over 2 is equal, and I'm just taking this term out right now and simplifying it, is equal to 4/2 plus I minus 1 over 2. And all I did here is make it where they have a common denominator. So I multiplied this by 2 and divided by 2, and I got 4/2. But now I can combine these two terms, equals 4 plus I minus 1. I'll write that out. 4 minus 1 plus I over 2. And this equals 3 plus I over 2. Alright, so now I can rewrite my summation. I equals 1 to 4. We have our big parentheses, our outside parentheses. Then we have 2 times 3 plus I over 2 squared minus 3 plus I over 2 minus 1, all of it multiplied by 1/2. Now that we got this figured out, we just got to simplify a lot. So we can go ahead and figure this part out. Well, 3 plus I over 2 squared, 2 will go to 4, 2 squared is 4, and then we just FOIL this the 3 plus I part. So we get our outside term is still 2. And now we have in parentheses, FOIL the 3 plus I squared, which is going to be I squared plus 6I plus 9. And 2 squared, the denominator squared, is just going to be 4. Minus, we can go ahead and break these two terms up. 3/2 plus I over 2. If you see what I did there, I just separated both of them. 3 plus I over 2 is the same as 3 over 2 plus I over 2. Minus 1, close parentheses, everything multiplied by 1/2. Alright, so next, we can distribute our 2 here. We can distribute our 2 here. What color should I use? Should I use dark blue? Alright. Well, let's distribute that 2. We have now our 2 disappears, and we can bring a 2 out here. Well, let's do, so 2 times, we'll bring our 1/4 out, and then 2 over 4 is 1/2. So now we have I squared plus 6I plus 9 over 2. And if you don't understand how I did that, this right here is the same as saying 2 times 2, and then this 2 canceled one of these 2's, and now I have a 1/2 here. Minus, let's distribute our negative sign, 3/2 minus I over 2, and then this still stays minus 1, and we still have everything being multiplied by 1/2. Alright, now let's just have everything on its own denominator. I don't like blue, it's too dark. I squared over 2, I'm just breaking up each one of these terms, plus 6i over 2 plus 9 over 2 minus 3 halves minus I halves minus 1, all multiplied by 1 half. And don't forget, I know I'm not writing it, but the summation thing is I goes to 4. That's all still out there somewhere. Okay, now, I'll write it so we don't forget. I equals 1, 4. Now we can start combining some of these terms. Well, 9 halves minus 3 halves. This is going to be 6 halves. And 6i over 2 minus I over 2 is actually going to be 5i over 2. And then we just have the I squared over 2 and minus 1. We can't combine those, but we will be able to combine the 1. So actually 6 halves, I'll go ahead and write this down. We'll do it again. So let's go to our summation. I equals 1, 4. We have I squared over 2. Let's put our parentheses. I squared over 2 plus 5i over 2 plus 6 halves minus 1, all multiplied by 1 half. From here, we could combine our 6 halves minus 1. Well, 6 halves is actually 3. So this is actually 3. This is 3. So 3 minus 1 is 2. So now we have I squared over 2 plus 5i over 2 plus 2, all multiplied by 1 half, which gives us our final, before we start to use our formulas, which gives us I squared over 4 plus 5i over 4 plus 1 half times 2 is 2 over 2, which is just 1. Now, where we go from here, we break up each one of these summations. Okay, so we're going to have something like, or we're going to have, our summation is I equals 1 goes to 4, I squared over 4, plus our summation from 1 to 4, 5i over 4, plus our summation 1 to 4, 1. And we can pull out all the constants, and a constant is just a number without any variables. In this case, i's are variable. So we can pull out a 1/4 from here. We can pull out a 1/4 from here. Should I use yellow? We can use yellow. So I can pull out a 1/4 here. And we have our summation. Now it's just I squared. I equals 1 to 4. Plus, we can pull out a 5/4 here. Our summation, I equals 1 to 4. Now we just have I. And we have a constant already in here. We'll just leave it. We get a summation, I equals 1 to 4 of 1. Now let's look what we have here. We have an I squared, an I, and 1, which is a constant, a C. And if we scroll back up to the top, which is a long ways up there, we have summation formulas that match all of those. And I'll go ahead and let's see if this works. Control copy, Control paste. Alright, so we have these summation formulas right here to tell us what to do in scenarios like this. Well, what's I squared? Alright, I had a little technical difficulty, but we'll try to start off where I left off in the last video. So we had broken this down, and we could see we'd start using our summation formulas. And I'd already started writing it down, but I squared actually turns into n plus 1 times 2n plus 1 And our n in this case is equal to 4. And you can look right here, the top of the summation symbol is n. Well, n is equal to 4 in this case. So let's go ahead and write that one down. So what do we have here? We have 1/4. This thing disappears. We don't need it anymore. N is equal to 4. So we have 4 times 4 plus 1 times 2 times 4 plus 1. All of this over 6. And that's our first term. Our second term, we don't need the summation anymore. We'll just put a brackets or parentheses. Well, what's I break down into? I is this over here. N plus 1 over 2. And n is again 4. N is going to be 4 for all of these. So I goes to 4 plus 1 over 2. And our last one is 1. Well, what's 1? 1's C. 1's a constant. So now we just have what our C is evaluated. Well, when we have a C, it's just a constant, no I values, no variables, anything like that. We just multiply it by n. So 1 times 4 is 4. And we can start adding all this up. We get 4 times 5 is 20. 4 times 2 is 8. So 9. Then to 180, we have 180 over 6, all times 1/4, plus 5 times 4 is 20 or 10. 5/4 times 10 plus 4. And I'm just going to plug this in on my calculator. 1/4 times 180 divided by 6. Well, this is 7.5 plus 5 divided by 4 times 10. We got 12.5 plus 4. Well, what's 12.5 plus 7.5? That's 20 plus 4 is 24. And look at that. All this work, all of it, to get 24, the same value we got with just a few steps earlier. Now, this won't always, I mean, just adding up the rectangles won't always be possible, but when it is, you can see, especially when you're dealing with just 4 rectangles, it's a little bit easier just to go term by term and kind of skip this if you can.